This is a 3D printed RC crane with outriggers that can lift up and stabilize the entire model, as well as a telescoping boom that can reach over 3 feet in length. Even a self-loading counterweight system and everything else you might need to lift an RC excavator multiple feet into the air. Though what's even more impressive is that it can even lift. Kicking this wonderful project off, I made a 2D sketch to get an idea of the overall dimensions. Because this crane is so long in real life, it's going to be a struggle to fit certain pieces onto a 3D printer bed. For example, an LTM 1300 is around 1500 centimeters long, and this current sketch is 45 centimeters long. For argument's sake, we'll have a minimum bed size of 235 by 235, which is the size of an Ender 3. So if you have an A1 or Bamboo P/X series, you shouldn't have any issues printing the largest parts of this model, as the bed size on all of those is 256 millimeters. P.S. The scale for this model will be around 1/35. Opposed to other projects where the first thing I tackle is the electronics, that's simply not going to be feasible here, as I honestly have no idea how many motors or servos it will take to get everything functioning to the degree I want. What I mean by that is that the number of problems I need to solve on this project is far and away greater than anything I've done before. For example, let's add up all the different functions this crane has, starting with the 6 sets of wheels that are all steerable, the extending motion of the front and rear outriggers, the actual stamping/stabilizing motion of those outriggers, the rotational movement of the crane chassis, the boom lift, the telescoping boom ability, the winch to reel in and out the crane cable, a lifting mechanism to attach the counterweights, and then of course some miscellaneous lights and extra slots for future upgrades. As is my goal with all of these projects, I want to design them in a way that you, the wonderful audience, have a fighting chance at 3D printing this out at home and making your own one-of-one RC crane, just like all these people did with the RC excavator. A couple special mentions: this green excavator made by Project Stew, and this white plus orange combo made by Pichelka. I mean, let's be real, I may have designed the RC excavator, but this guy made it look good. Next, I dived right into problem number 1, designing a twin axle system where each of the 4 wheels have freedom to turn and are all powered via one motor. The first thing this screams is U-joints. I've made it a point to avoid these on my projects, as at this scale you'd think they'd be super fragile. But after printing out 1.0, 2.0, and 3.0, I discovered that as long as they're printed with the layer lines running perpendicular to the applied force, they're actually plenty strong. So with that question answered, I printed out a test chunk of the truck chassis and installed the gears that transfer power from the N20 motor to the U-joints. For some reason, I decided to add suspension to this model too, because apparently I'm a fan of pain. My first thought was to link the wheels on each side together so that if one goes up, the other goes down, but after squinting at it really hard for a solid 30 minutes, I threw that out the window and settled on a more traditional linkage system, which has a lower and upper control arm. I then designed and tested a variety of these 95A TPU rods, with some being a mesh and others solid, though I ended up settling on this 2-wall design that bends off to the side. Overall, this simple component was a ton of fun to make, and I'm curious to see how these hold up in the long run. Despite my best efforts, the angle between the output gears and the wheel hubs is extremely steep, meaning the U-joints need to have an outrageous amount of rotational freedom in order to not bind up when the wheels are turned and spinning. I made some simple off-road tires out of TPU, which can be pressed right onto the hubs. Sending power to the N20 motor via my power bench, I finally had my first taste of a somewhat reliable system, where the wheels could be moved up and down to simulate bumps and everything wouldn't bind up right away, though there were still a couple spots causing this right axle to bind and move on its own accord. For steering, I linked the 2 tires on each side together with a bar, and after redesigning everything 4 to 5 times, I finally had a finished set of axles that worked really well. Though right when I was just starting to believe this project could actually be possible, this started happening. The 3D assembly for my model had so many moving parts that I was completely maxing out my computer's RAM. Now granted, looking back, I could have made this a lot better by properly fixing some of my components in place, but hey, now is as good a time as any to, well, first clean out the inside of my computer because it's getting a little dusty, and then upgrade the RAM from 16 gigs to 64. This did help run my assemblies more smoothly, but I have a feeling a new computer is on the horizon, as while this one is great for a quick dyno game session, CAD and Premiere Pro have definitely taken their toll on it over the last couple years. Right, so with the U-joints not binding and the suspensioning, my only real concern is that these MG90S servos might not hold up when actually weighted down with the rest of the model, especially if I hook these steering knuckles to the middle ones. But that's a problem for future me. First, let's talk Outriggers, which if you don't know are these awesome legs that extend out from the base of the crane to give it a more stable platform to work on. Nothing too crazy about them, so it should be pretty easy to recreate, right? Wrong! The smooth brain solution is to slap a motor on the extending motion, then on each foot. Now times that by 2 because there's 2 sets of Outriggers, and that's 6 N20 motors. AKA way too many, because 1, that's a lot of extra electronics that are required, and 2, N20 motors aren't free, so let's see if we can eliminate a few. Maybe take it down from 6 N20 motors to 2 N20s and 2 servos. We just have to supply power and a signal to the servos, so that makes our life easier on the electronics side. I first thought about using some rails with teeth on them that could then be pushed out on either side for the extending motion, but ran into some stabilizing problems, such as where to keep the actual supporting structure, as I'm working with limited space here. Next, I came up with this twisty thing that when one end is secured and the other spun via a motor, it will either extend or retract. Overall, this seemed super promising, so I made a 4-piece variation that didn't work. So I tweaked it and tried it again. Small improvement, as now it would move slightly when I hit it with a hammer. After all of these attempts, I eventually got this magnificent beauty, which can be printed as one part and moved with the gentlest of movements. The upper edge of each piece is expanded out slightly so that when it reaches the bottom of the next piece, it stops and prevents it from coming apart. I printed out the entire front frame to start getting an idea of how everything would fit together, specifically the Outriggers. This N20 motor will have a helical gear that will power the extending motion when swung down. That's right, the N20 motor will also be able to swing back and forth thanks to this servo, where it can then come in contact with either of these 2 helical gears, which will twist these extending arms that will then hook into these bevel gears that will then spin an M4 bolt that will then push this foot down. And now if you think this whole plan is overcomplicated and
not good,
you are absolutely right, and is why I scrapped that whole idea as well as the next 2 iterations to make this instead. Rather than having the N20 motor swinging around like some gymnast, it now simply moves back and forth in a linear motion, where it contacts either the right or left extending barrel. And check this out. At first, the barrel will just extend out, but when it reaches its max length, it then locks together and spins as a whole, which then turns this bevel gear with a threaded rod on the inside. Now that's some folded brain engineering. Unfortunately, I couldn't fully test this because all the right angle N20 motors I ordered were complete and absolute trash. I ordered 6 to 7 different brands, all of them around the 27 to 50 RPM range, and they all pulled 0.17 amps versus the 0.6 amps, which tends to be about the average on these non-worm gear right angle motors. I took one of each apart just to get an idea of what made the good one good and the bad one bad. The good one on the right has much neater wire windings than the other, and I'm also guessing the wire is of higher quality than the other. Now, while I wait for some others to try, I decided to carry on with the front cab, where the seats slide right into the main shell with a satisfying snap. That's right, for the first time in Professor Boots history, the cab isn't just a hollow shell. I then proceeded to print sheets of U-joints, hubs, and A-arms, with the goal being to get the whole truck portion of this build driving around under its own power. The assembly of these parts is the closest I've come to 3D printed Legos, though I must say the number of screws this model requires is quite substantial, but nevertheless necessary. With all 12 wheels attached and rolling, I finally started getting excited about the build, as up until this point it had been weeks and weeks of just CAD. These gears moving at all is a testament to the power of coffee. Though my potentially better right angle N20 motors still hadn't shown up at this point, that didn't stop me from mounting and hand turning each of the 4 Outriggers. You genuinely don't want to know how long that took, as they're geared really low to achieve maximum lifting capacity. This is about a 15-pound box of car tire weights, which I placed on the frame to get an idea of how the Outriggers would hold up. All in all, I'd say good. I quickly ran some tests using just my power supply bench, where I ultimately decided to swap out the 300 RPM and 20 motors for 200 RPM and 30 motors to give it a little more low-end oomph. Plus, these N30 motors are only about $3 on AliExpress. I hooked up the servos and motors to a mini dump PCB just to temporarily get an idea of how to drive around. At first, it was pretty rough going, as the MG90S servos did end up having trouble moving all four wheels, especially with any kind of weight. So I swapped them out for these much stronger PTK servos, which worked beautifully, and then connected the rear tires on each side together using another steering bar, which ultimately completed the circuit and made for much stabler steering. Right now I just have the middle wheels tucked up out of the way until I decide what to do with them, but as you can see, having the rear steering in addition to the front helps so much with turning this bus of a project around in a small space. Then what's even cooler is the crab walking ability, which is not entirely useful, but still a cool flex. So with the truck running well, I moved on to laying out the crane portion, arguably the most important part of this build. The biggest struggle I faced within this assembly was getting the boom to imitate a real telescoping boom. I thought about doing what I did with the Outriggers and having a collapsible barrel on the inside of the structure, but coming back to the limitations of 3D printer bed sizes, each chunk of the boom needs to be split into two and then joined together after the fact, all while still being able to slide past one another and be structurally sound. Applying that to the extending barrel would be extremely difficult, if not impossible, without making the barrel thick. Instead, I cheated a little and just placed another right angle N20 motor at the base of each extendable section, which this model has 3 sections in total, meaning 2 extend out from the base. Not only is this a risk, as I still haven't received any right angle N20 motors that are up to snuff yet, but I also need to figure out what to do with the wire running to each motor, as they will be shifting inward and outward constantly. I was able to blaze through the other pieces relatively quickly, as in a way it was pretty similar to the excavator, so I could take what I learned there and apply it here, with one notable section being the winch cables. The main cable that pulls in and out the crane hook has this gear set that lowers the speed and increases the torque from what will be a 100 RPM N20 motor. Then going out on a limb, I also decided to try and add a counterweight lift that can fully function on its own. In real life, these cranes have counterweights trucked in separately, where they are then placed/stacked on the crane truck bed by the crane itself, and when enough counterweight is loaded, it can spin around and pick it up. Now my implementation is to run a second N20 motor through another set of gears to this pulley, which will have a little ball attached to the end of a rope that can be raised and lowered. After self-loading the weights, you can spin around and use the ball to hook the bottom weight and lift them all up. Now, will that work? I have no idea, but we'll hopefully soon find out. Overall, everything turned out shockingly good on the first attempt. Even my little crane cab interior is pretty sweet, if I do say so myself. I did underestimate a couple things though, such as the power required to actually lift the crane boom. I'm using a 12 volt, 600 RPM N20 motor here, which has enough power to lift it when it's fully retracted, but with one section extended, it really starts to struggle. Never fear though, as simply dropping that down from 600 RPM to 300 RPM will give us roughly double the amount of torque. This helped a lot, and I was even able to add some extra weight via my hand. My next problem was in the winch system. The counterweight gear train ran smoothly, but I didn't account for the overall length of the N20 motor, as the gears ended up overlapping with the end of the motor, which is obviously no good. So instead, I moved the N20 mount further up and away, then completely eliminated the gear train for the crane hook, and just made the final gear much larger and directly meshed with the N20 motor to reduce friction. Now, to verify the extending boom concept would work, I took one of my many subpar right angle N20 motors and inserted it into a boom section. Shockingly, it moved with a little help, which I think is a good sign, as a standard quality one shouldn't have any trouble. I put on the second extension plus the main boom head, and my oh my am I glad I only did 3 sections of boom, as this thing is huge. I apologize for showing all the background color, but I simply couldn't fit this thing into frame otherwise. With the CAD for the crane portion almost done, I moved on to laying out the electronics, which, believe it or not, was its own problem to solve, and here's why. supply. The truck has 4 N20 motors and 4 servos, which means it needs a whole bunch of pins from our development board. But the crane portion has 6 N20 motors, as well as some auxiliary pins for future upgrades and attachments, which means it also needs a whole bunch of pins from our development board. And well, in reality, one ESP32 development board by itself can control 6 N20 motors and a couple servos fully maxed out, which leaves me with a severe shortage. At first, I thought about doing what I did with the excavator and using a port expander, but that would ultimately result in either having more power wires, with some running 5 volts and others 7 volts, or 2 separate battery power supplies, one in the truck and one in the crane, which I ultimately ruled out and decided to instead have one power supply and 2 ESP32s. The ESP32 in the truck will be responsible for connecting to the controller, and then I'll just send commands via serial to the second ESP32, which will tell it what motors to move. For example, if I write 5 over serial, the second ESP32 will read that and know to spin left. If it's a 1, it will know to lift the boom, etc. That's the general idea anyway, and after breadboarding it all out, it seemed promising, so I made the printed circuit boards and with a quick click, got them manufactured.
One eternity later.
After populating the PCB components, I was able to verify they worked by uploading my crane code, which, to briefly touch on, uses a library called BluePad32 that allows you to connect to the ESP32 via a PS4/5 or Xbox controller, along with a wide variety of other miscellaneous controllers. The library BluePad32 relies on a dependency called BTStack, which is absolutely amazing, so a special thanks to Blue Kitchen and Ricardo for the great resources. Links to their libraries in the description. I finally got some top tier right angle worm gear and N20 motors. When fully stalled, they pull upward of 0.6 to 1 amp, which is worlds better than what I could find previously. And with this newfound power, we can finally test out these Outriggers, which will be the most magical, most mechanical, most miraculous thing you have ever. After making some small adjustments, these things work so much better than they have any right to. I did use a little bit of this white lithium grease, which definitely helped to take some strain off the motor. And after seeing how much of a difference it made with the Outriggers, I went back through and applied it to the gear train as well. I updated the crane base with everything I learned from the first prints and decided to officially tackle the counterweight plates. Each plate will be loaded with about 5 ounces worth of these car tire weights that can be found for relatively cheap. You can then stack up to 3 of them for a grand total of 17.6 ounces. I think I'll make a wider/heavier alternative that can fit more weights in the future, but for now, this will help balance out the boom. To load or secure the weights to the crane, this proof of concept version shows how this little ball will be lowered down inside the weights, where it can then latch onto the bottom plate and lift the whole stack. But again, this is just a proof of concept and will need a couple tweaks. The main spool for the hook can hold about 1.5 meters worth of this heavy duty nylon thread, but a more pressing matter is finishing this telescoping boom now that I have quality motors to work with. I use some really flexible silicone covered wire that when the boom comes in, it can be coiled/squished in between the sections. I gave a generous 20 millimeters of room just for this to happen, which after adding these little prongs to prevent the wires from getting sucked into the gears, worked rather well. Side note, tree supports on the boom sections are an absolute lifesaver as they don't completely clog up the rat gear like normal supports do. For the finishing touches, both aesthetically and functionally, are these TPU wheel flaps, followed by the first hook iteration, which ultimately couldn't be secured to the front hook holder, so I changed it to a single rear-facing hook. It works much better, though you can always swap this for your own custom hook to fit your own needs. An electronics hatch that can be easily opened and closed, some headlights, a drastic size increase of the rotational ring gear, which makes for a smoother and slower rotation, as well as a more stable platform when lifting objects. To go with that, I also shifted the entire crane assembly back by about 20 millimeters on the truck bed, which improved the overall proportions. Some multicolored prints to make the mini lift name pop, as well as that Prof Boots branding. Some cable management pieces to keep everything on track when the boom is extended. TPU mats on top of the boom and storage box, which really helped to balance what was before an overwhelming amount of yellow on this build. The final iteration of the counterweight system, where I swapped the heavy-duty nylon thread for floss and made it so when placing the weights, just place them slightly closer than you think you'll need. Then as the crane spins around, it will push the weights into the perfect position where you can then lower the ball and secure the weights. Releasing the weights is as simple as one might imagine, where you can simply lower them, pivot, and raise the ball again. Finally, you know I had to make the crane cab tilt, which I accomplished by connecting it to the main boom motor holder, and as it tilts up, the cab does as well. Before moving on to real world test number 1 and number 2, I'm going to run through all the features the mini lift mobile crane has and how they connect in to your actual game controller. So as you can see here, I'm using a PS4 controller, but you could also use a PS5, Xbox, or some generic Bluetooth controller to do this. It doesn't really matter too much. So to actually turn the thing on, there's a little switch down in the inside of the chassis that you just flip that. You'll hear all the servos initiate, and then to pair it, you're just gonna press the share button and then the PS button. You'll see the lights flash, and then they'll turn blue, and that's how you know it's connected. Right now, in default, it is in truck mode. And the first thing you're gonna do is throttle. So throttle's on the left joystick, and that's forward and backward. And it's proportional too. So if you move it just a little bit, it'll go slow. If you move it a lot, it'll go fast. Your next control is steering, which is on the right joystick, and that's just left and right. That's also proportional. Now to go from normal steering to crab walk steering, all you do is press square, which will enter you into that mode. And now instead of the two sets of axles pointing separate ways, they'll point the same direction. So if I go right, all the wheels are gonna pace that way, which lets you crab walk. And then if you press square again, it'll return you to normal steering mode. To extend the outriggers and stabilize the model, it's the top bumper buttons and the lower trigger buttons. And if I want to extend this front left outrigger, I'm going to press L1, which is the top left bumper. And then to pull the outrigger back in, you're simply going to press circle, which will reverse the direction and pull it back in. Now if I want to do two on the same side, I'll just simply pull the two on the same side. Then to stabilize the entire model, you'll of course do that for the other side as well. But for now, moving on to the crane portion of this build, which is arguably the most important part, you're simply going to press triangle, which will enter you into crane mode. And the first thing I would do is, of course, detach the hook from the front of the truck. And then I'm going to extend out the telescoping boom, which is up and down on this right joystick. If I can actually get this, there we go. And then from there, up and down on the left joystick is tilting this main boom up and down. And then left and right on the left joystick is the actual crane pivot. And all of the controls that are attached to the joysticks are going to be proportional. So if you move them a little, they'll only move a little bit. If you move them a lot, they'll go really fast. The counterweight winch is also on the D-pad, so that's going to be left and right. At this point, now that we have the mobile crane pretty much buttoned up and ready to go, it's time to vote for a fourth project. Meaning you guys voted in the mini dump truck first, and then we had the excavator, now we have the crane. Now it's time to choose that fourth one. So make sure to drop a comment down below with whatever piece of machinery you want to see next. Maybe for some extra credit, you could choose a make and model as well. And then whatever has the most comments will be the next project. Meaning it could be a forklift, a dozer, a semi-truck, etc. You name it, and enough other people do, it'll happen. But anyway, enough of that. Let's get a move on to real world test number 1. Part 1 of test 1 is trying to make this 90-degree turn, which other than taking out what might have been a sidewalk in real life, it did pretty good. Part 2 is a really steep ramp, which the crane stands no chance against, as the approach and departure angles on this thing are horrendous. But giving it my all, the first thing I tried was making it super back heavy by spinning the crane around to possibly wheelie over the top, which did let me get my front tires on, but I was still stuck. Next, I tried putting my crane hook to work by latching onto my filming light in the hopes to winch myself over, though I ended up getting caught on the Outriggers, so fail on that front. But on a less extreme note, it can drive over small bumps like this book. Test number 2 is going to be a recovery mission on these Pringles, which are stranded on these boxes. To do this, I first need to load the counterweights onto the crane, and I'll be the first to admit my crane skills are still in development, as I spent way too long trying to grab this counterweight loading attachment. With enough time though, it did finally happen, and I was able to load the weight. For the fun part, I snagged the mini skiddy and hoisted it to the top, where it then secured the Pringles and returned to where it could be lowered back down like something straight out of Mission Impossible. As you can probably guess, this is a beast of a model to 3D print and put together, and I can only really recommend it to those who have at least built one of the other models first, such as the RC skid steer or excavator. So if you want to jump into this world of DIY 3D printed RC construction equipment, I'd suggest starting with one of those. Regardless, consider checking out the Professor Boots workshop on my website, professorboots.com, where I have step-by-step guides for each of these models and how to go about sourcing the printed circuit boards, 3D printing the parts, and coding the microcontrollers, etc. Joining the workshop goes a long way in helping fund the development of these DIY 3D printable RC construction projects, and for those of you who are already members, I seriously can't thank you enough. It's been absolutely awesome seeing all of your builds, especially in places like maker fairs. With that, I thank you so much for watching, and I'll see you here soon with whatever build you, the community, votes in.